Good afternoon, everyone. Thanks for joining. And today we are talking about AWS Reinvent Recap Part 3 under AWS Tech Talks Session 5. And today's focus will be on new feature enhancements that were announced around AWS Glue and other AWS data and analytics services. We will spotlight on AWS Glue and particularly on AWS Glue data quality. Let's take a look at AWS Glue as a service and what has happened over the past 1 year in terms of new feature enhancements and particularly around reInvent 2022 towards end of the year, the features that were announced. So over the past 1 year, AWS Glue has gone through a bunch of feature enhancements. And if you have not looked at what's new in AWS Glue for a while, I think a lot of these features are very useful in terms of simplifying some of the very commonly done functions on AWS Glue. So early part of last year, there was a new job run insights and a new version of find matches that was released. Middle of the year, there were a bunch of announcements around new capabilities on Glue, serverless capabilities on Glue. So instead of spinning up a Glue development endpoint that is charged every second, you can actually use something called interactive sessions where Glue service automatically spins up a Spark cluster behind the scenes when you need it. And when you no longer need it, it is automatically shut down. So you don't have to keep paying for a development endpoint while you do your development and testing. Similarly, there are features like auto scaling. There are newer forms of notebooks like Glue Studio notebooks that were announced. And similarly, later in the year, there was a flex mode of Glue workers, which is similar to Spot instances on EC2, where they have spare capacity of worker nodes that they are not currently utilizing. And if you can sacrifice some discontinuity in your job and can recover from it, and you don't need your jobs to finish in a particular time window, you can take advantage of the flex worker mode and you can get up to 30 to 40% discount in cost. Similarly, there were enhancements available in terms of smaller worker node sizes for small streaming jobs and auto scaling for streaming as well. And late last year, they integrated Git into the Glue management console, where for an individual Glue job, you can connect it to a particular Git repository, either on GitHub or AWS code commit. And you can also select a particular branch in that repository and then check in and check out code, which defines the job and its parameters directly into that repository. So that makes version control for small teams very easy without having to worry about CI/CD pipelines and deployment using cloud formation, etc. So that was at a glance the kind of enhancements that they did on AWS Glue last year. But come reInvent, they had a bunch of very major announcements around AWS Glue and its capabilities. So this is at a glance some of the highlights from that, and we will spend a little time talking through them over the next few slides. And AWS Glue data quality is something that we will focus particularly on for today's session, and we understand how it works in detail. So one of the major announcements was the version 4 of AWS Glue Engine that was announced in reInvent. So this brings us support for Apache Spark 3.3, which is the latest version, and then support for Python 3.10 and Scala 2.12. So the optimizations that are available to have performance Spark distributed data processing running are much improved here. And then there is a much improved Redshift integration as well available with Glue now. So according to some benchmarks that they have published using the TPC dataset, this is supposed to be around 10 times faster than what was possible before. So yeah, if you're integrating with Redshift, do check out, make sure that you are using AWS Glue version 4 for any new work that you're doing. So similarly, this new version of Spark that is supported has support for distributed pandas API on Spark. So that's it's something that you are handling. That's probably beneficial to you. One of the other things that they have started supporting now is distributed processing using not just Spark, but also native Python. So some teams may not have skill available in PySpark. They may be more familiar with Python and they may want to do data processing using Python, but are currently limited by the single node limitation that Python shell option in AWS Glue limits them to. So using Ray, you're able to actually write data processing jobs using any native Python libraries and run them as Glue jobs, but you can then distribute those data processing jobs across multiple nodes, even when using native Python without using Spark. So the way this framework works is that you have something called a Ray core library that behind the scenes manages the distribution of data processing across a head node and a bunch of driver nodes, worker nodes. And based on the amount of data that you throw at it, it will spin as many nodes as required behind the scenes to run that in a distributed fashion. So if you look at a quick sample of how it works using pseudocode, right? If you have a Python function that does some data processing on a set of data, you can add a decorator around that Python function to invoke the array functionality associated with that function. And whenever you define that task and instantiate that task, behind the scenes, it will run up a number of worker nodes. So those are called array actors. And those are just stateful functions that are executed as separate functions on separate nodes. So every time you instantiate that class, that function gets run on a separate thread on a separate node. So that's how you are able to distribute your data processing across multiple nodes. So this is brand new. So this is Ray is one of the frameworks out there that allows you to distribute your Python processing across multiple nodes. So it is not just for data processing, but also for distributed machine learning and AI model serving. But those functions are not utilized because AWS Glue does not focus on machine learning as much as it does on serverless data processing. So a part of the Ray library is what is utilized here. There is a similar package or library available called Dask that also allows you to distribute Python across multiple nodes. Currently, there is no support for Dask in AWS Glue, but hopefully it might be supported in the near future. How you get started with this is in your AWS Glue Studio. When you start a new Glue job, you have a new option now where you can select a Ray script editor as the way in which you want to create your AWS Glue job. And once you go there, you have an option of either attaching a file that has your Ray script, or you can directly program it in the script mode on the console itself. So that's how this feature works. Similarly, there is a new plugin that AWS announced called the Cloud Shuffle Storage plugin. So using native Spark, if you run a very heavy job and if your nodes run out of memory when they are processing a particular slice of data, they need to do something called a shuffle, and that data in memory sometimes spills over into the storage associated with that node. And if that storage is exhausted, that node will fade. And recovering from those kind of situations is very tricky. So to avoid that kind of situation, the Cloud Shuffle Storage plugin enables you to spill over not into your local storage on the node, but into your cloud-based storage like S3 or any other location, so that you never run out of storage in that situation. So you are able to recover from that and spin up additional nodes and pick up from where we left off without your job failing. And this Cloud Shuffle Storage plugin is also available if you want to utilize in any of your other Spark jobs, even without using AWS Glue. But it is natively supported by AWS Glue now. And with AWS Glue 4.0, they have announced native support for open source data storage formats like Apache Hudi, Delta Lake, and Apache Iceberg. So all three are very popular data lake storage formats that give us time travel, ACID transactions, and other benefits. So with native support coming in AWS Glue 4.0, the amount of overhead in terms of using connectors and doing configuration, etc., would be minimized. So this should be exciting for a lot of work that we do on data lakes and these open source formats. Similarly, there is something called custom visual transforms that AWS Glue now supports, where a common set of transforms that you do on your data can be packaged into a reusable piece of code that can be published within your account, discovered through a management console interface like what is shown in the screenshot, and can be reused by your team or other teams in your account. without having to do complex Spark coding in every job where that kind of transformation of data is required. So this encourages reuse of code and modularizing your code, and also basically minimizes the deep Spark knowledge that is required across large teams, where a small core team can work on these complex reusable transformations and make them available. And these transforms are available to be used whether you are using Visual AWS Glue Studio based Glue jobs, or you're scripting, and you can also use those transforms in your code as well. This, you can think of this as similar to what Lambda layers does for Lambda functions, right? You modularize your code and publish them as Lambda layers and reuse them in a number of Lambda functions, so that you are not repeating or making your code heavy, and you're also not having to do the same kind of change at 4 different places or 10 different places should you require a change in a common logic. So that's the same principle at work here as well. All right. Now comes AWS Glue data quality. So AWS Glue data quality purports to address a very common use case where, in addition to ingesting, transforming, loading data into various data stores, etc., you often need to know at some level of confidence how healthy is your data, or what is the quality of data that you have in your data lake or your data store. And oftentimes that requires you to spend a lot of time exploring the data, profiling the data, gaining insights either through your notebooks or other profiling tools, or write custom code, looking at data on a regular basis and coming up with some statistics or metrics. So this is a very common need in any enterprise, and there are some non-standard tools available or custom engines available. But it just saw a need to standardize that and also utilize the AWS Glue serverless ETL platform itself to minimize the amount of heavy lifting that is required there. So they created a brand new functionality within AWS Glue console that makes it available with a few clicks. The ability to assess the quality of data or health of data in your data store. The other complexity here is to define what it means for data to be healthy or data quality to be high, right? So at a technical level, whether you're talking about particular tables, columns being fully populated or having missing values, or the values are not right, they don't they look like anomalies or outliers, etc. So all those kinds of typical profiling of data can be converted into data quality rules, but usually that requires somebody to spend a lot of time going through huge volumes of data across each and every table, and then coming up with some rules and then validating those rules, and then implementing custom logic to actually do that evaluation on a recurring basis. So that's where this new feature that is currently in preview makes it very simple. So let's dive into a little bit of detail here, right? So like AWS Glue itself, this AWS Glue data quality service is also serverless. So you define what you want through a management interface, but the underlying infrastructure or Spark clusters or data processing logic that needs to run on various forms of compute, you don't worry about any of that. You're just paying based on how much data you are evaluating and how much time is your job, data quality evaluation job taking, right? We'll look at pricing model a little later as well. And then not only does it make you capable of managing large volumes of data and coming up with rules yourself, and you can configure those rules yourself. But this product also has out-of-the-box recommendations on what a good data quality rule should look like. It gives you a starter set of rules, and it also recommends some rules that may be relevant to you based on the particular data set that you have by profiling that data set automatically for you. And there is also a new data quality definition language, DQDL, that AWS has created to make it easy to declaratively define what my rules are for a given data set in terms of data, measuring its data quality. And you can use that DQDL to very easily define the various rules instead of writing long blocks of code in Python or any other programming language to deal with measuring this data quality. So we'll look at an example of that in later slides. And there are 2 or 3 different perspectives or personas built into this tool that give you different views of data quality at different stages of the life cycle. And there is data quality for data at rest and data in transit that is taken care of by this tool. So at a high level, when data is ingested, stored, and then served to various downstream consumers of data, there are two personas or 2 perspectives that you can think of. One is the data at rest, as it is stored in a particular physical storage location. You can talk about or assess the quality of data as it stands there or as it is at rest there. So this is typically the perspective of a data steward who is responsible for the data quality of a particular data store. The new capability that they have launched enables us to assess data quality of data at rest using AWS Glue data catalog as the gateway into that data store. And then the second persona is that of a data engineer who is responsible for moving data from one place to another or transforming the data for a particular business objective. In both these cases, the data engineer has a responsibility to maintain data quality through those transformations, either when they are reading the data and before applying transformations, or after applying those transformations, they also want to ensure certain minimum data quality before writing it to a target data store. So this, you can call it as data in transit. And even here, there are features available through this new AWS data quality product that allow you to plug into your existing AWS Glue-based ETL pipelines, some checks on data quality, and then some alerts and notifications or even actions that you can implement based on what is the result of the data quality evaluation there. Diving a little deeper into these 2 personas, right? The data steward, when they are looking at data as it is stored or data at rest, they can look at the AWS data catalog and select a particular data set or a particular table. And then they can decide to apply a particular rule set that defines these are the 10, 20, or 30 different rules that I will apply on this particular data set, and evaluate whether this data set meets these rules and how well it meets these rules. And once I finalize the set of rules that are appropriate for that data set, I run an evaluation job using those rule sets against the data and come up with a result of whether the data set is meeting those rules, how many rules are being met or how many are failing, and for what reason are they failing, right? And those results are presented back to the data steward, who can then review those results and take any necessary actions, like going back to the owner of the data and getting the data quality issues addressed and data being re-ingested. So that's one view. The other view is for data in transit. Like I said, the data engineer may be responsible for moving or transforming data from one place to another. And as part of their ETL pipeline, they can add a data quality transformation using the data DQDL rule set. And then when the job executes, when it reaches that particular step, the DQDL rule set is applied against the data set that is being processed by the pipeline, and the results are then made available at the end of that step, which can be utilized to either mark the job as success or failure, or maybe write the offending data set to a dead letter queue or a kind of a Dropbox in S3 location, so you can come back and look at what was wrong with the data set that made it fail the DQDL rule set, and you can rerun the job once you have addressed the underlying issue. Both these are facilitated by the engine, which has this open source DeeQu framework that AWS has made available. So this was launched a few years ago, and some companies have started using the DeeQu framework in their own ETL pipelines in their own way. But now it is available as a managed service natively integrated into AWS Glue. AWS has used the same framework within their own internal projects at petabyte scale. So they are fairly confident that it works for their customers as well. Since it is open source package, you are welcome to integrate it into any other data pipelines that you have also in place. So a glimpse of the DQDL language that they have created for making this easy, right? So if you look at the screenshot and particularly the code block within the screenshot, each line is a complete rule in itself. So if there are 45 lines in this particular DQDL code block, there are 45 rules that are defined. You don't have to do anything else other than a one-line declarative statement of what you expect the data set to behave as or to contain when it comes to a particular column or particular aspect of data quality, right? Let's take the very first line that is visible, line number 24. So is complete empty tag. So empty tags being the name of a column in the data set that you are applying this rule set to. And that column should be complete, as in it should have values for the entire data set. It should not have any missing values. So similarly, the second line puts a limit or a range on the standard deviation that that the empty underscore tags column values have, and it should fall between two limits, right? So similarly, you can put an upper limit on the value of a column itself, or you can what else? There are some examples. Okay, you can have a list of values in which a particular categorical value can fall. It could be a year or month, for example, or you can have a regular expression you can apply on a particular string field, or you can also use SQL based rules like the last example that you have is a custom SQL rule that lets you put full SQL based aggregate queries, etc., and then you can apply a rule based on that. So all of this makes it not only easy to define the rule, but also easy for somebody who's not very conversant with programming or code, or even SQL for that matter, to understand what this rule is, right? So they can quickly tell you whether these rules are right, whether these rules are right for their business, or they might even be able to modify it themselves when it is simplified to this level. What you see on the right side of the screenshot is the DQDL representation in the right syntax, but there is a visual form of that on the left side where you can, using visual interface, you can add new rules and modify the parameters or delete rules, etc. So both of these make it easy for you to define a rule set and look at a rule set and modify it. All right. There are some out-of-the-box rule types that AWS provides that you can utilize. So there are rules around consistency of data in terms of its data type, or whether what is the length of that, or a pattern within that column that it should follow. Similarly, there are some accuracy-based rules that use some statistical parameters like mean or standard deviation, distinct values, etc. And then you have completeness in terms of not having missing values or missing values with a particular threshold. So at least 95% of the rows should have a value in this column. You can have that kind of threshold when it comes to completeness. And similarly, there are some integrity related constraints around primary key and uniqueness as well. So like I said, there is a custom SQL option available. So if none of the out of the box rule types really meet your need, you can go ahead and write a SQL that kind of summarizes or encapsulates the logic that you need for your custom rule, and then make it part of the same rule set as well. You don't need to separately evaluate that custom rule. You can make it part of the same DQDL rule set. So when it comes to pricing, given that it basically is built on AWS Glue, the pricing is nearly identical to running any ETL job on AWS Glue. So 44 cents per DPUR is what you pay for your AWS Glue jobs, and that's what you pay for your data quality evaluation jobs as well. So there are some examples on this slide that tell you if you run a job for around 5 minutes with around 2 DPUs, you end up spending 7 cents on that. So there are similarly, depending on how big your data set is, how wide your table structure is, you might be running this job for a few minutes. And similarly, you might be spending anywhere between a few cents to a couple of dollars on those kind of jobs whenever you run that job. So on the console, this is how it looks like, right? You are familiar with probably the Glue data catalog and the way you look at tables and columns and other metadata around those tables. So when you look at a particular table, there is a new tab available in the Glue console called data quality. And under that tab, you have the option below to manage multiple rule sets that define data quality rules for that data set. So the buttons here on the right side give you an option to evaluate a particular rule set by selecting one of the rule sets tagged to this table, or you can create a new rule set, or actually let it just run a profiling job and recommend a rule set for you. And that recommend rule set is actually very powerful in that it doesn't require you to come up with rules all by yourself from scratch. It goes and looks at your entire data set in the actual underlying physical table, and based on the distribution of data that is available in the various columns, it creates a set of suggested rules. So you can actually look at, once you click on recommended rule set and run that rule, you might come up with, you might be shown a list of suggested rules that looks like this in DQDL, right? So like I said, it is fairly readable. So there are some completeness rules around with some thresholds that 96% or more of this column should have valid values. Birthday should fall in these values, but year should fall in these values, etc. So some of these, this is not super intelligent in the sense that it won't take the column name and say, okay, this is supposed to be a birth year, so let me put anything in the 20th or 21st century is valid, right? It doesn't do that level of intelligent rules, but it is more of a statistical data profiling. So it found that all these values are in the year column in your data. So it considers that as valid and suggests a rule to you. But if it makes sense for you to simplify this rule to say birth year should be greater than 1900 and less than maybe 2025, for example, you can just manually modify this one rule, keep every other rule the same, and then apply that rule set. So you have that flexibility of either taking the suggested rule set as it is, or making minor tweaks where maybe your data set is not in a great condition, so there are a lot of outliers. So a lot of these maybe maximum or minimum thresholds that this job comes up with are not really correct for your particular data set, right? Then you can definitely replace that with a more reasonable or intelligent threshold, and then apply the rule set and not accept the rules as it is. So when you create a rule set like that and run an evaluation job, you will get a set of results saying the DQ job has passed or failed, and then hierarchy of all the rules under that DQ job will also be flagged as passed or failed. And in this example screenshot, that shows that the data quality score is 100% because 22 out of 22 rules have passed. So that's a happy scenario, and you can opt to write all these data quality evaluation results to CloudWatch so that you can maybe do some dashboarding or do some event-driven functionality downstream based on the quality signals from the dataset. And if the DQ job fails because some of the rules have failed, the data has not met some of those rules, you will get a result that says DQ failed. And if you filter for failure status, you might get a summary of individual rules, their definitions, their status, and the reason for the particular value that did not meet that criteria. So in this screenshot example, you have a data quality score of 95% because out of 41 rules defined, 39 have passed but 2 have failed. And the 2 that have failed are these, right? There is a rule that says column values under the column passenger count. Something is trimmed here. I think it says something like it should be less than or equal to 8. This is some data set about taxis. So taxi trip cannot have more than, let's say, 7 or 8 in any case in a single trip. So there is a particular value that has some 208 as the number of passengers. So that particular record caused this rule to fail. Similarly, the total amount charged, maybe there is a rule that says it should be less than $500, but there is something that goes into almost $100,000. So this has failed the rule evaluation. So that in this manner, you are able to very easily create rules, evaluate rules, and quickly get results, numeric results with the details for drill down to evaluate how good the data is against any rule set. And you can have multiple rule sets. You may have a very stringent rule set that you apply only at intervals of, let's say, once a month or once a quarter. But for daily data ingestion, you might have a slightly more permissive rule set where you expect reasonably good data as long as there are no absurd values, for example. But then there is some amount of processing or massaging that you do on the data to make it work. So those kind of options are possible in this. So similarly, that was the example that we saw in the last few screenshots was for data at rest, when you're looking at AWS Glue data catalog interface and then creating and running a DQDL rule set against an existing table. Now, in AWS Glue, when you're doing your ETL jobs, if you're using AWS Glue Studio, for example, and visually building your ETL, there also you have an option for data in transit to do some evaluation of data quality. So now you have a new transform available called Evaluate Data Quality. And when you use that node, you have an option under Transform tab to apply a DQDL based rule set. It could be 1, 2, or 20. Any number of rules you can apply here and modify by hand if required. Or you can go to the rule set that you have already attached to the table in Glue Data Catalog and use that rule set as it is here. You apply those rules, and when the job executes that particular step in the job, it will apply all those rules and come up with the same kind of metrics that you saw in the other screens. And based on the result of that evaluation, you can make the job fail at that step if the DQ overall doesn't pass. So that's one straight away big lever that you have to stop bad data from entering any particular target data set. But even if the job doesn't fail, you can use the output of this transform step in deciding what to do with the data, or take the job in any different branch or direction, right? And similarly, you can make these DQ metrics available in CloudWatch for any loosely coupled event-driven solution downstream. So that's roughly what we wanted to cover in terms of new features and functionality in AWS Glue specifically, and AWS Glue data quality, which seems fairly interesting. In a lot of customer scenarios, we are working on solving similar problems. In some cases, we are creating very custom solutions for our customers in the absence of any ready-made solutions. So a new service like this is very exciting for us to try our hands on and maybe deliver value much more quickly to our customers, instead of doing custom code and then taking on the operational overhead of managing all that code for a long time to come. So with that, my monologue is done. And if you have any questions or any ideas or contributions, please open your mic, share your thoughts, and we have, let's say, 5 minutes or so that we can spend on this before we launch into the bits.